Hello everyone, welcome back to MAT052. We're going to continue it with our reviews this week. This is Chapter 8 review. I'm going to go over some of the stuff that we covered. We did the basics in the regular sections, and I'm going to kind of go through and do the complete hypothesis test, and we'll just do a quick review before we get started with some of those problems. So here's our fundamentals of hypothesis testing. How do we test someone's claim about a population parameter? You either see it in an advertisement or somebody just says something. I think the proportion of people that like Mountain Dew is greater than 70%. If 70% is less than 70%, the mean gas mileage that we get with this is 25 miles per gallon. And we would like to go and basically check and see if that value is correct. So assuming that the population size is too big, meaning we can't measure each data item in the population, I can't go and get a check the miles per gallon for every car that's out there. What we need to do is just take a sample, and then we're going to use the sample's corresponding statistic to see just how unlikely the claim would be for being true. So remember, for hypothesis testing, we really can't say absolutely that it's going to be either true or false, but we can say how likely it is or how unlikely it is that it would be true. So the test value from the sample, we just call that the test statistic, and depending on which population parameter, the mean, the proportion, we have a different test statistic formula, and just like confidence intervals, it all depends on which information we're given. Usually, if we have information that we can use from the population from basically some previous study or from some other method, then we're going to use that information if we can. So the calculation is like the measure of position, a z-score. We use the standard error instead of the standard deviation to calculate it, and it can be either a z-score or a t-score depending on the test performed and the information that we use. Okay. So the hypothesis testing, the test structure, all hypothesis testing requires that same test structure, okay, or the framework. So basically this framework we build around the claim, okay? So we start with a claim. We don't have a claim of something that we're testing for, we don't do anything. The claim gives us, and what we do is we start with the claim, and then we would like to determine the likelihood of being true or false, that claim being true or false. So unfortunately, this claim is usually in the form of just a statement. I think the mean is greater than 27 miles per gallon, okay? So I have to, first off, convert that claim into a math statement. I get the math statement, and then I form a second one. I start with that claim, and then I form a complement of the other piece of it. So it could be less than, then I would need to have greater than or equal to. If it was equal to, I need a not equal to. So I want to form these complement statements where both can't be true at the same time. I can't be less than a number and greater than a number at the same time, or greater than or equal to, okay? So what I want to do is then assign the null hypothesis and an alternate hypothesis to those complementary statements. It has nothing to do with the claim when we assign the null or the alternative, and the null is just not the first thing that we see. It is the one that has the equality in there. Okay, it requires that equality to be a null hypothesis. And then the alternates must be either less than, greater than, or less than or greater than, which is the not equals. Okay, and then we're going to determine the test from the alternate hypothesis, left-tailed, right-tailed, two-tailed. Okay, I go and I grab that sample value and I calculate the test statistic. And then for region testing, I find the corresponding critical values, left-tailed, right-tailed, or two-tailed. And then that separates the rejection region from the failed to rejection, or the failed to reject. So for p-values, I just calculate the probability of the test statistic being more extreme in the direction of the test, the left-tailed, the right-tailed, the two-tailed. I reject or fail to reject the null hypothesis. I'm always going to reject or fail to reject H0. That's the only thing. And then I have to reconcile, because the claim could be either the alternate or it could be H0. It depends on what that claim is, if it included the equals or it didn't. And that's how I go. And then I just need to do my statement to reconcile which one of those are. So claim complement pairs, here's the claims about the mean. So I could have this, I could say, I'm going to use this one as the claim. I could say, well, the mean is greater than n. So I form a complement pair, mu is less than or equal to n. Remember in trichotomy days from your math, if I have two numbers, they could be either comparing two numbers, one could be less than the other, could be bigger than the other, could be equal to the other. So there's actually three different conditions that we can do. But when you're doing it within ALEKS and our textbooks, they just say, look, we're going to shorten this thing up to be greater than n versus mu equal to n. Which one would be H0 then? The equals, this would be H0 over here to the right, alternate to the left. Here's our next one. We could say, oh, it's less than n. That would be the claim that we're testing over here. And our complement statement would be greater than or equal to n. Again, in ALEKS, it would just say less than n versus equal to n, because if this fails, the equals is going to fail all the bigger ones here. Okay, and this would be our H0 again because it has the equal. This would be the complement because it does not. Your claim could be, oh, I think the mean is greater than or equal to n. I write that down as a statement, a math statement, and then I do the complement. This would be the mu less than n. Now the claim here is H0 because that has the equal, and this one does not, so that would be the alternate statement. You could have said mu less than or equal to n. Whoop, I went back too far. Less than or equal to n. Again, I would write my complement greater than n, assign H0, it would go with this because of the equals, and there would be my greater. So again, this could be mu equal to n versus mu greater than n if you're doing it, depending on the textbook and if you're doing ALEKS. So here's why I like to include that, because if it's mu is equal to n, this should be less than or equal to. So if you look back up here, and if I just had the equals, you'd have to go over here to see which one of the test. But if you have everything there, you've got all the information. Here would be H0. I'm testing against exactly n. It could be bigger, it could be less, and that's when we go with here. Here's my little not equal to, less than or greater than. Population proportion would be the same thing, except we're writing it in terms of the proportion being bigger than a number or less than a number. This will be P0, and if you're back here, this would be mu sub 0, and then this would be P sub 0, would be that number that you see in the formulas. Okay. Again, they're giving you this. When we're doing hypothesis testing, we're using directly with alpha. Confidence, we were doing a confidence interval C, 98%, 95%, and then found the alpha, the area. Here, they're giving us directly. When you're doing a hypothesis test, you're going to be given alpha directly. So that's kind of one of the key things between the two. One's a confidence level, 98%, 90%, and then the alpha hypothesis test, 05.02. Okay. 8.3, so when I'm doing, I have to match the test statistic basically a z-score or t-score, and that's in the formula. It's either going to say t is equal to something or z is equal to something. And if I'm doing a t-score, I've got to do 8.3 with degrees of freedom equal to n-1, just like we did confidence intervals. And then for z-scores, when it says z is equal to something, I can go to either 8.2 or use the little table because it doesn't depend on the degrees of freedom, the sample size. I've got everything directly. And here would be the alpha that you were given here, and then I'm going to use, depending on the test, left-tailed, right-tailed, two-tailed. And remember, this was the less than. If I had in my alternate statement like mu is less than, that less than would point to the left, left-tailed. Mu greater than some number, right-tailed, and then the two-tailed would be the not equal, less than, or greater than. That's when I would use the two-tails. And here would be my critical values that I'm using in there to separate the regions. When I'm doing a student's t, if it has a t is equal to something in my test statistic, when I do regions, I've got to do critical values based on the student's t distribution, and that's table 8.3 in the book. I'll have to go down, find the degrees of freedom, which is one less than the sample size. I go up here to find the corresponding area in the right tail. So this could be a one tail or two tail. If I two tail, I divide it by 2. It could be alpha directly. And then I just go find it through here, and then I come calculate. Okay. So let's look at one. Let me get started. Let me kind of switch around my camera so we can do some whiteboard stuff, and we'll get started. So let me see if I can get this done. Down, out, and up. Let's go here. Down, up. There we go. Okay. So, playing the market. Let's kind of open this up. I'm going to kind of go down here, and then I'll open this up a little bit so we can see the whiteboard work. So the Russell 2000 is a group of 2,000 small company stocks. On January 21st, 2013, a random sample of 35 of these stocks had a mean price of $26.89 with a standard deviation of $23.41. A stock market analyst predicted that the mean price of all 2,000 stocks would be $25. Can you conclude that the mean price differs from $25? Okay, so we're going to work through, and eventually we're going to get down here when we get into D of here's the alpha level that we run the test on. Okay, so basically we're going to start, we're going to develop the state, the null, and alternate. We don't do that directly. We start with the claim, and I recommend always doing this. Start with the claim and then working it through. So I like to start with the claim. So I kind of put my claim over here, claim. Let me go ahead and spell that out. The claim here is that a stock market analyst predicted that the mean price of all 2,000 stocks would be $25. Okay, the mean price, so that mean price, I'm going to use the me because this is the all of them, is equal to 25. Okay, so that's the claim. Okay, but now I need a complement. So I'm going to leave this alone until the very end. I'm not even going to worry about which one is the claim and what is the claim all the way up until the end, and we were going to reconcile. So I need a complement, and that complement to the equals is basically mu not equal to 25. And this is the same thing as less than, mu is less than 25 or bigger than 25, but not equals. So once we get this, we always start with a claim. Again, I build a complement, and then I assign H0 and H1. Okay. H0 always has an equal. Okay. So this is the one that was the equal. So this gets my H0, and that's the only reason, not because of the claim. I don't even look at the claim and the complement anymore. H0 goes with the equals, H1 gets the other one. Okay, so this is what we're assuming. H0 is assumed true. And we're going to test the likelihood that it is true. So let me kind of go up here a little bit more. Let me kind of build this out so you can see this a little bit better. Okay, so we've assigned this. Here's our equals, our H1. Okay, that's the null and alternate. Which test? So this is the first one, assign. My next thing is determine the test. H1 gives us the test. Okay, if it's greater than, that's a right-tailed. If it's less than, that's a left-tailed. And that not equal, which is the same thing, it's either less than or equal to, that's the two-tailed. I've got two tails in here. Okay. So which one do we have? We've got this one. So that tells we've got a two-tailed test. Okay. So basically I go ahead and I start developing what this thing looks like. In confidence intervals, I always had two tails. If I have a right tail, I'm going to draw a little area over here with all the alpha in there. If it was a left tail, I'd draw my little area over here with all my alpha in there. And then a two-tailed, I've got alpha over 2 because I split that up. And the alpha that we're going to do is the alpha 0.05. So each one of these is 0.025, 0.025. I'm doing it by region. I'm going ahead and I develop my region here as we go through. I go ahead and have this all set up. This is a rejection region, FTR. FTR is fail to reject. RR is my rejection region. Okay, and all I have to do once I get these critical values is do the test statistic. Now that's the same no matter what, but now I've got to get critical values. I've got to actually look at the test statistic to see if I am a T alpha over 2, is this a T alpha over 2 or a Z alpha over 2? I would call it T alpha, Z alpha if it's one test, the alpha over 2. So I don't know if I need that or that, and I need the test statistic formula, which is going to tell me. Okay, so what do we have based on all of this information? Let me kind of pull this. So if I can get up here a little bit, or to the side, let me get to the side. So we've got an X bar. If I went out and got my sample, I have from a sample of 35, so N was 35, and I found out my mean price, the X bar from the sample, 26.89, with a standard deviation, S, is 23.41. So this I know the S because I'm talking about I had a random sample of 35 of those stocks, and they were the ones with the standard deviation. So I don't know sigma. Okay. So for here, for this information, sigma unknown, I've got to do a z-score. So here, let me pull back up again. So here is this is a z-score calculation. So my test statistic z-score is my X bar minus mu 0, that's whatever the hypothesized value is, and then, sorry, let me erase this. I don't know what sigma is, so I've got to use a t-score S over the square root of m. Okay, so that's the test statistic value, and now I can go ahead and start working on these things. So my T is just going to be my X bar, 26.89, minus my hypothesized value was my 25, and then 23.41 is my S, divided by the square root of 35. This is the test statistic. Okay, so I'm going to go over here on my calculator real quick. I'm going to calculate that. Make sure when you're calculating this thing, you put parentheses around that in your calculator and that. That tells it that you want to do this calculation top. You want to do all of this first. You want to do this divided by that second. And then you're going to go divide that into that. So let me run these numbers real quick for you. 26.89 minus 25 divided by 23.41 divided by the square root of 35 and 0.4776. Okay. So now we're doing, if we plotted that, this would be 0 in here. Okay. Let's kind of go back down here. The 0 would be here. 0.477 would probably be back in here, 0.4776 over on this side. And I just want to know what that region is. So this is when I need to go find the CV of T alpha over 2. And that would be, let me go, I'm going to go use my calculator inverse for the T to get those. And my inverse T, my area to the left, 0.025. Degrees of freedom, I'm going to enter my df. So my df is 34. That's my n minus 1. And this is 2.032. And this is minus 2.032. So between these two, if anything was outside greater than 2.032 or less than negative 2.032, I would reject, and that would be rejecting H0. Okay. So here's my critical values. My test statistic was here, so this is in the fail to reject region. So here, I'm going to go ahead and kind of clean this up a little bit here. Just like that. And so we're basically fail to reject. And who do we fail to reject? Not the claim directly. We're always testing against H0 that we're doing. So we fail to reject H0. Fail to reject their claim. Okay, so that happens to be H0 happens to be the claim. So how we kind of word this is kind of the weaker one of the two. There is insufficient evidence. Sufficient evidence to reject the claim. In this case, it's a wide margin. So anytime we fail to reject it, we want to kind of do there's insufficient evidence either to support the claim or reject the claim. And this time we're just rejecting the claim. Okay. Okay. So there's where we reconcile the two pieces of it. And that's the conclusion that we need and to reject the claim. And we also need to add at the alpha level, and what we tested it as, that's at 0.05. There's insufficient evidence at alpha is equal to 0.05 to reject the claim. We need to add that in there because this always determines whether we're going to, what separates the FTR and the RR. And if that was too small, if that was opened up a little bit, then we could have the possibility of rejecting. Okay. So let's move on. That's kind of that one. Go down to the next one. Oh, sorry. And that's kind of the only one. Oh, here's our, okay. Let me put this down here for the second. Facebook, a popular blog, reports that 60% of college students log into Facebook on a daily basis. The dean of students at a certain university thinks that the proportion may be different at her university. Different. She polls a simple random sample of 200 students, and 134 of them report that they log into Facebook daily. Can you conclude that the proportion of students who log into Facebook daily differs from 0.60? Okay, so let me kind of get this out, clean this up from last time, and we'll get started here. Okay, all right. So what do we want to do here? We want to test the claim that the proportion of students who log in daily differs from 0.60. So we want to start with the claim again. So here's our claim. What we want to do is that P is not equal to 0.060. It differs, okay? Could be less than or greater than with the differ statement. So as always, I want to do a separate complement. Here, I'm going to do 0.60. not equals equals, and then assign my H0 and H1. H0 always goes with that, with the equal sign. So there's my H0. There's my alternate, and the alternate tells us again that we're going to do a two-tailed test. That tells us there. This is actually less than or greater than. This could be over here or over there, and that tells us the test. So there's our null for part A. There's our null. There's our alternate. We need to compute the value of the test statistic, but let's go through and set everything up just like we're going to do. I've got a two-tailed, so I've got two tails here. The alpha, later on, is going to tell us to test this thing at the 0.05. So I like to go ahead and fill all of this in. So I've got a two-tailed, so I need alpha over 2, which is 0.025. 0.05 divided by 2. So the area here, the area here. Okay. This is my fail to reject region. Rejection region over there. Rejection region over there. Okay, and now we just need to do, I need to have these critical values, but that depends on if I'm going to do a T or a Z test statistic. So now I need to bring in my formula. So the test statistic for P looks like it's a Z value, and this is P hat minus P0 all over P hat 1 minus P hat over N. It tells us we got a Z-score. We can go ahead and calculate this real quick, but then we got to do the critical values that match our Z. Okay, so this is going to be, so what was our P hat that we had over here? Let's go over here. So our P hat, it says the poll, from the poll, out of 200 students, 134 of them logged in. So that's 134 out of our N of 200. So our P hat is just going to be the 134 over 200. And that is 0.67. 67% of those. Okay. So we just need to do 0.67. They hypothesize that's the P0. So that number is the P sub 0. Minus 0.60. 0.60. I'm going to go ahead and write 1 minus P0. That's going to be the 0.40. And then over N, sorry, not the P hat, but the P sub 0 for this. We're doing the claim, we want this to match. So this would have been like for the confidence intervals. Here we want to use P0, 1 minus P0, because there's a claim about what the population should be, and we should use that. So here, that's why I'm using this 0.60 and the 0.40, and then over our 200. So I'm going to run these numbers in my calculator. Let's see, 10.4 divided by 200. And that becomes all. Zero. So this value for the z-score is 2.0207, or I'm just going to put the 1. And then I'm going to plot this out here, somewhere out here, but I need the critical values. Okay, so I'm going to do the critical value z alpha over 2. That's because that's a two-tailed test. Z 0.025. So if I go back up here, if I go to this one, it's going to tell me I'm doing my alpha level, the full is 0.05, and I'm doing a two-tailed test, so that divides that by 2, which is plus or minus 1.96, 1.96 minus 1.96. I just plot that in there, and then the 2.021 is somewhere. My test statistic is 2.021, which is in that rejection region. Okay. So here we reject. Who do we reject? It's always H0. So we reject here. So if we rejected this one, we can cross that out. So this has got to be the correct version, HA, and that in this term is just the claim. Okay. So here I'm going to kind of clean this up a little bit so I can finish up our statement. And then that'll finish us up. So at the alpha, let's go ahead and get this out of here. At the alpha equal 0.05 level, alpha equal 0.05 is what we're doing. There is, hold on, there is sufficient evidence to support the claim that P differs from 0.60. Okay. So that kind of finishes it up on that one. I think that's all that we need to work on as we get back down here. And again, take a look at those problems. They're going to be look just like this. Go through, clean up what I've got, put them in there, and then submit them for attendance and grading. Okay. Be neat. Put the full thing up there to make sure that you know all the elements that are in the hypothesis test. And we'll see you next time. Have a good week.